Alright, this video is about joint Lewis structures. So here is just I summarize the steps from 1 to 5, and then our textbook break into more steps, but basically the same concept. The first step is always you find the sum of valence electrons of all atoms. Alright, So the first step is you sum all valence electrons. If it's an ion, don't forget you need to add the corresponding electrons. It's a -1, you add 1, -2, you add 2, right, etc. If it's a cation, now we need to subtract. Remember, electrons are negative, so always go the opposite. And then we need to find the central atom. It's the least electronegative element. Also, many times the compound is in the format of, let's say, ABN, with the, N means greater than 1. Then we basically just put an A in the center, if A is just a single one atom. For example, CO2, then we will put a carbon in the center because there's only one carbon. Now, and then you put the oxygen around it. But you see here, carbon is also less electronegative. I hope that you still remember the trend, the electronegativity. If you know the trend, then you know carbon is less because carbon is on the left of oxygen. The next step is we connect the outer atoms to the center one by single bonds. I also call this as a skeletal structure. Skeletal structure is fitting for this time of year, right? It's October. Skeletal structure. Alright, so basically we connect all atoms. And the next one is you fill the octets of the outer atoms. Alright, remember what's the octets? It means 8 electrons, right? And then number 4, you fill the octet of central atoms with the leftover electrons. If you don't have leftover electrons, then you want to see, okay, is my central atom has an octet or not? That's the next step. If it does not, you start to form multiple bonds. Okay, so I'm going to break the steps, this flow chart into individual steps. The first one, how do we sum of all valence electrons? For example, for this, for POCl3, you have to know what's the valence electron for each atom. For example, for this, phosphorus, we have 5, right? And then we only have 1. Oxygen, we have 6. Cl, each one has 7. You should be very fast with determining the valence electron number. Again, you should have your periodic table with you as you do problems. And that's periodic table will be provided for the exam as well. So each one 7 valence electron, but we have 3 of this. So we times 3. And then now total we got, you just add all up, right? 5 plus 6, that's 11. 11 plus, this here is 11 plus 21, that's 32. Alright, most likely, the sum of valence electron is also in an even number. If you got an odd number, you may want to go back to see what's wrong. And the NO2 minus, again, similar. So nitrogen, I have 5 valence electrons. Oxygen, 6 for each. I have 2 of this. And then now, don't forget, because this is an ion, you see the little line there, that means -1 charge. So we now have to, this plus that, have to plus 1. Alright, so now 12 plus, again, 6, again, is an even number. Alright, so you can do the rest of it. All right, so next step is you find the central atom. The central atom is the least electronegative. And the never hydrogen, why is it never hydrogen? Can you put a hydrogen in the center, connecting two other atoms? Let's say here's the A, here's the B. Why this is not possible? Okay, notice here, if you have a hydrogen here with the two arms, like with the two bonds, how many electrons are surrounding this hydrogen now? Okay, yeah, you should always view this each electron look just like each bond is 2 electrons. Alright, so now I'm going to change the color. If you view this as 2 electrons, you can see already there are 4 electrons surround this hydrogen. That's why this is not okay, because hydrogen maximum 2. That's why hydrogen always in the end. Alright, so now I'm going to put the step 3 together with this on this slide. Draw a single bond, and then you just basically connect all. You want to draw a single bond, you want to connect all atoms, make a skeletal structure. So for example, this one here, let me change my ink color back. So we have this. I want to put the N in the center. You say, how do you know to put the N? Like I said, if it has A, B, and then more than one B, you want to put B around A. Alright. And then, in fact, also nitrogen is less electronegative. That's it. We form this skeletal structure. And here, hydrogen never in the center, so I'm going to spread around. So that's the skeletal structure. And the last one, for this, I will most likely give you if this is on the test, I will tell you, oxygen is connected to carbon only, something like that. And then hydrogen is connecting to carbons. To the carbon. Alright, so now that's our skeletal structure. You don't need to draw more, and then that's just connect all the, we call the peripheral atoms to the center one. Next step is you complete the octet around each the end atoms or peripheral atoms. For example, here for chlorine we put 6 around, right? But it's a help that if you keep track of the electron numbers. For example, previously this we have a 32 electrons total. We put down 4 bonds, that's 8 electrons. So minus 8, and we have 24 left. So now if I put the 6 around each, make an octet, and right now 6 for each. This is 6 electrons here, and here's 6, 6, 4 times 6, that's 24. So originally I have a 32 minus 8 on the bonds and minus 24. That's it. We have a 0 electron left, and now you stop here basically, and then you can see next step. You want to see if it's happy or not. All right. Let me do one more problem here. So NO2 minus. So we put 2 bonds here, so that has 4 electrons. We have 14 left, right? 14 left. So I'm going to put 6 around this oxygen. Why I put 6? Because here is already a bond. We want to make it an octet, right? So for this octet, I'm going to put 6 over here to make 8 around this. This oxygen has 8 electrons. Alright. And then I'm finishing this step. So I would like you to take a moment to do this problem. By the way, my PowerPoint on Canvas has the structure already drawn out, the dots. Now, so you can check your answer. I'm going to move on to the next step is, if there's any leftover electrons, we put on the center atom because the outside atom already has the octet, all have octet already. So remember we said this one has 0 electron left. So remember this is 32 minus 8 minus 24, that has 0 electron left. So that's it. We are not going to do anything. There's no leftover electron. For this one, 18 minus 4 minus 12, we have 2 electron left. If there is a 2 electron left, let's go ahead and put it on the center one. Okay? And then again, I will leave that to you, the last molecule. Now, the next step is the final one. If the center atom has less than an octet of electron, then we begin form multiple bonds. So remember, this is how we got for this. For the NO2 minus. What's this name? This is still, remember, this is called the nitrite ion. Nitrite, not nitrate, because there's less oxygen. So this one here, POCl3, this is all happy. Everybody is happy. And 0 electron left. So this is good. How about this? We say this structure has something wrong here, because the middle one, the nitrogen here, is not happy yet. Why nitrogen is not happy? How many, you always look at the electron numbers, right? How many electrons are surrounding this nitrogen now? 1, 2, 3, 4, 5, 6. Only 6 electrons. So everybody want to have 8. So then now, what do? We say, oxygen, you need to share with nitrogen. Like I tell my kids all the time. Now, so we are going to move the electron around by forming double bonds. Okay, so I'm going to just let this oxygen share. In fact, later, we are going to learn about resin structure. Of course, the other oxygen need to share equally. So there is another structure. So that's going to be form double bonds from this oxygen. And that we called resonance structure. So these two both exist. I'm going to draw. So both structures are right structures. I'm going to draw an arrow here. This stands for, whenever you see this, this means resonance structure. Okay, I have a slide on that. Alright, now, you see here, then everybody is happy. Everybody is surrounded by 8 electrons. So that's our final structure. In fact, these two are equal, right? They are symmetrical. And the same reason for this, carbon here is not happy, and then a double bond need to be formed. Alright, sometimes it could be triple bond, meaning 3. If a triple bond, meaning 3 lines. And that's 6 electrons, right? Each bond is 2 electrons. Alright, but if the atoms are already satisfied with making double bond, you don't need to go further. Only if it's still not happy, then we form triple bond.